All right. Tiny screen version, of which you have another version on your computer right now, hopefully. All right.
All right. Hi, everyone. Welcome to CS106L. All right.
Woo.
Yay.
Yes, absolutely.
All right, next slide. So the game plan for today, by the way, we're on slide 2, okay? So game plan for today, we will first do a quick welcome, then we'll talk about why you want to learn C++ and why you should take CS106L. And then we'll go through some quick logistics of the class. Then we'll go through some history, the philosophy of C++, and then we'll write our first C++ program.
First C++ program.
Yeah, in standard C++. Okay.
Absolutely.
So just a quick introduction. My name is Avery.
Yes, and I'm Anna, and our emails are actually written right up here. And we just want to emphasize, email us at any time with any questions you have about C++, about general CS major, about life. We're here to talk to you guys and be a resource. Awesome.
All right. Yeah, so first let's get started about why you want to learn C++, okay? So one thing that I've heard a lot of people say is, okay, C++ is a dying language, right? People have said Java is a dying language, C++ is a dying language. Any new language you hear about, in a couple of years, someone's going to say, oh, it's a dying language, go learn a new language, right? But C++ is still very relevant in computer science today, okay? For example, if you look on slide, what's the slide?
6.
On slide 6, that is the current, the computer scientists, they use this index to figure out how popular each programming language is. And you can see that C++ is still way up there, right? Yeah, so behind Java and C and Python, C++ is still a very commonly used programming language. That's the reason why CS106B teaches C++.
Exactly.
And one of the favorite things that I learned in the past couple of months is that before Python was slightly more popular in C++, but recently C++ just overtook Python as one of the most popular programming languages. So yeah, well, one of my friends teaches a similar class but in Python, and we're constantly having this competition whose language is more popular, whose language is more relevant. Yeah. Okay.
Right now, C++ is winning.
Right now, it's us. Yeah. If you just type in C++ on Explore courses, you'll get a whole list of classes which use C++. Okay. So if you look at slide 9, I guess.
Yes. 8.
Slide 8. You'll see a colorful list of all the classes which just barely mention C++ on their course description. And for a lot of these classes, you can see in all fields of engineering, you will see C++ being used everywhere there. Obviously, you'll see some in C++ in CS classes. While one thing I found really interesting was in music classes, when they're trying to make acoustic musical design, they use C++. And one common thing that we'll be coming back to is C++ is very good for anything that requires good performance. Okay. So C++, companies that use C++. If you ever want to get an internship, if you ever want to get a job at one of the companies that you see on the slides.
On the screen in front of you.
Well, you're in luck because C++ is used in all of these companies. And in fact, if you think about almost any company in the world that uses any sort of technology, there is some sort of C++ that's being used there. Okay? For example, the browsers. Browsers are extremely complicated. Okay, browsers are a really complicated piece of software. If you used Google Chrome, you can look at the source code of Google Chrome, and a lot of it is written in C++. Okay. Software that's written in C++. One ironic thing is if you ever learned Java, the virtual machine that Java is implemented in, that is implemented in C++. Okay, so very ironically, other programming languages are implemented using C++.
Absolutely.
Yeah, and a lot of this you'll see a common theme, which is these higher level languages which are seemingly easy to use, Java, Python. Underneath them, the language that powers all of these other languages is C++. And as I'm going to keep coming back to this, C++ has very strong performance. That's why in the back end you'll see C++ being used so often. All right, any people here are gamers? Avid gamers?
Or that are willing to admit it.
Okay. Well, a lot of games, they're written in C++. And the reason is because a lot of these games, they require very strong, very high performance. You go to the Apple Store, for example, or you go to some laptop store, you'll see these laptops which are specifically made to play games. And the reason for that is because lap games require very strong performance. Right? There's a lot of graphics moving around. They have to control some of the keyboard maneuvers. So you'll have to know the laptops have to be able to run very fast performance. And for the application itself, C++ is a very good language to do that. Right? Here's a very cool thing. C++ is not just an earthly language anymore. Okay? There is C++ code that is running on another planet right now. Okay? On Mars right now. Well, actually, I don't know if it's right now. Is it right now?
Still right now.
Still right now. Okay. Yeah. So on Mars, there is a rover which is running on C++.
Yeah. It died, but it's still there, so we'll count it. Yeah.
Okay. Good.
It's
Good
true.
point. But the source code is still there.
Yeah, which is to say that you guys, as the next generation C++ programmers, are in charge of bringing the next rover onto Mars. So, yeah, this class will be for that as well.
Yeah. Okay. There's this quote. I don't want to read all of it, but essentially the idea is learning programming is really cool in that you sometimes just get to randomly dab in other areas of science and humanities, because computer science is just very powerful that can be used everywhere. And C++ is a language which, even though you might not see it used in some places that require Python, but C++ is a very general programming language that we'll be explaining more soon.
Absolutely.
Okay. Let's talk about why you want to take CS106L. And just a quick check. How many of you right now are in CS106B? Okay, B or X?
Perfect.
Okay, so all right, so a lot of you are right now in CS106B or X. And so I'm going to do a quick comparison to how this class is different from that class. Okay? So first, one thing you'll notice about CS106B is it's called programming abstractions. Cynthia this quarter decided to add in the phrase in C++, but normally CS106B does not focus on C++. Mm-hmm. Okay? While our class is called standard C++ programming, our focus is C++. In CS106B, you'll learn a lot of important concepts like recursion, like ABTs, like pointers. These are relevant in basically any programming language that you'll use, which is kind of why, as a CS core class, we want to teach that language. Well, we want to teach these principles, because no matter what programming language you use, you'll use these principles. In this class, even though C++, because a lot of the things that we learn, like object-oriented programming, they're relevant to some other languages, but there's a lot of features that we'll look specifically at C++. And that's what makes C++ really cool. There are some things that you can only do in C++, but you can't do in other languages. Furthermore, let's see, what slide are we on right now?
We are on slide 18.
18, okay.
Yeah.
So in CS106B, you barely learn enough C++ to do all those abstraction things, but in this class, you'll learn enough C++ to do industry, to do research, to do your own personal projects.
Yeah, if you're considering whether to take this class or not, this class has been known to be really a sign that you can really program in industry settings. Because one of the things that I personally felt coming out of CS106B and X was that I had learned programming based on Stanford libraries. So libraries that Stanford had built to better teach the design principles of computer programming, but not really how to actually go out and build your own project. So this class is really, really good for that. Yeah.
Yeah, just a quick story. When I took 106B, I asked my section leader, can I put C++ on my resume now that I've taken CS106B? And they were like, well, 106B doesn't actually teach C++, right? The next week when you learn about like all the, like a vector, what a vector is, what a array list, what a map is, those constructs aren't seen in real C++, but we will teach you the equivalent of those in standard C++.
Yeah. And we love 106B and X, by the way. We're giving flack only because we are such a good co-class to take with those classes. Yeah.
Yeah. By the way, both of us were previous section leaders.
Yes, we were also both section leaders.
If you want to ask us about CS106B, feel free to do that as well. Okay. Let's see. Right now, C++ has a long history, and the C++ that you learn in CS106B, that's called C++ 98. Anyone want to guess why it's called 98?
The year 1998.
Yeah. It was developed in 1998, which to some is a little disappointing, right? Like, I'm at Stanford, I'm learning CS, learning C++, and I'm learning stuff developed 20 years ago. Okay, compared to like sciences, 20 years is pretty good, but that is a little old for technology. So in this class, we'll be learning about stuff that was in C++ 17. So 17 is like 2 years ago. Okay, yeah, because C++ is a continually evolving language, and these features, they've been used already, even though it just came out 2 years ago. Okay, so we'll be digging directly into that. Next class, and in fact, I think we'll just be jumping directly into a C++ 17 concept. Okay, C++ 20 is released next year, and that has been known to be like one of the biggest changes in C++. So we'll also take a sneak peek at what C++ is going to evolve into.
Absolutely.
Okay, let's see. Yeah.
Slide 20.
Okay, Stanford libraries. Cynthia hasn't talked about Stanford libraries, has she?
Not yet.
Yeah, not yet. Okay, she will on Wednesday when you learn about like file inputs, user I/O. Okay, but C++ is a pretty messy language. Okay, there's a lot of like tricky details, and what the Stanford library does is it basically abstracts away all the messy details. Okay, in your CS106B class, when you call like get integer, when you try to get input from the user, you don't have to deal with all that messy stuff. All right, but in this class, we'll dig into the messy stuff. Okay, so for example, if you click on the next slide, here's kind of the mindset that each class takes. Right, CS106B, your section leaders beg you, please just use get integer. Okay, if you try to use cin in CS106B, your section leader will be really annoyed at having to grade your assignment. Okay, and I say that because I've had to do that. Okay, so in CS106B, use the Stanford libraries because those are there just to make it so that it's easier to teach the concepts that are important. But in CS106L, we want to actually look at, okay, what does the Stanford libraries actually do? We'll actually look at the source code for that and learn how would you implement something like that if you wanted to. Yeah. Okay. Cool. Some goals of CS106L. Just want to quickly mention them. One is to learn what features are in C++ because there are a lot.
Yeah.
We don't want to memorize all these features, but one good thing is just to know that these features are out there. Because when you're faced with a problem, knowing what tools you have and being able to look it up later is half the battle.
Exactly. And you'll find with standard C++ especially, it's such a big community of just developers around the world working on it that they've built a lot of tools and algorithms already. So you'll see some things that'll blow your mind, especially if you've programmed a little before, as you will soon in 106B and X as well. Like things that you have implemented, C++ can do in one line. So yeah, prepare to get your mind blown. C++ has some really cool things that are built into it, like tools that we want to learn exist, as Avery said.
All right. Second thing is you want to be comfortable reading C++ documentation. Okay. So if you go to the Stanford library documentations, they're pretty straightforward. Okay. But like for example, go to the next slide. So let me just quickly explain what a vector is, because you haven't been taught what a vector is. If you've learned Python, there's this thing called a list. If you've taken Java, there's this thing called the array list. In C++, the equivalent is kind of like a vector. And if you want to create a vector, if you could just go to the documentation itself, there are like a ton of ways you can create a vector. And for a beginner, like when I went to the website, I was kind of overwhelmed by all this documentation. And what's really cool in this class is we'll actually be able to understand all of that after taking this class. Okay, so this is actually a pretty good outline of what we'll be covering. All right. So yeah. So one reason is we want to be comfortable on how to read C++ documentation. You don't have to memorize the documentation, but you just have to be able to go through it and figure out what you need to do your projects. Okay, finally, the last goal we have is to become familiar with design principles of modern C++. All right, so yes, we will encourage, there are some style guidelines that we have. We're not like, style-wise, in CS106B, we're really strict on style.
Yeah.
We'll teach you some like style tips that are relevant to modern C++,
Exactly.
C++ language.
Exactly.
Okay. Yeah, important. Our goal is not to memorize C++ syntax. All right.
Yeah.
Nowadays, your IDE even shows you what the syntax is. You never have to memorize what a syntax is. Yeah. You just have to know that this feature exists.
Exactly, that it exists. And Stack Overflow is our friend. Cool.
Okay. There's a roadmap of what we're going to cover.
Slide 24. Avery made it. It's super cool. It's very accurate to the topics we'll be covering this class.
Okay.
Yeah, actually, okay.
All right.
Cool.
You're covering this, right?
Yeah. All right, awesome. So that's sort of, that's our pitch to you for why to take this class. And if you haven't been convinced yet, talk to us after class and we'll definitely convince you. So logistics-wise for this class, on slide 26, this class is 3:30 to 4:20 Tuesday, Thursday in this room, weeks 1 through 9. So we won't be having class on week 10, and we'll remind you of all of this as the quarter goes on. So a couple of key links for you guys. One of them is the website cs106l.stanford.edu. That's where we'll be posting our lecture slides. Usually after our after lecture, we'll be posting code snippets, any big announcements or updates. That'll be on the website, so keep an eye on that. We'll be having office hours. We'll be posting an announcement on Piazza of when those are, which brings me to the next point, which is our Piazza. I believe every one of you guys should be on that now because you're looking at these slides in front of you. That's where we'll really be engaging with you guys and posting like real-time announcements. One thing is that CS106L is not associated with the layer, if you've heard of that through the 106s. Instead, come talk to us at our office hours or before class, or reach out to us, and we'll help you with that. Because section leaders aren't necessarily trained in standard C++. Assignments-wise, so this is a 1-unit class. So again, our goal for this class is to be a way for you guys to learn what you want to learn. So we're not trying to give you guys like extra work or anything like that. So because of that, we've tried to make this as chill as possible while still teaching you things and reinforcing the things that you've learned. So there are 3 assignments in this class, and you only have to complete 2 of them. And if you look at the roadmap that Avery showed earlier on like slide 24 or something, that shows you when the assignments will be relative to the lectures. The pro tip that we always give is that the first 2 assignments tend to be a lot easier for people than the 3rd assignment. So if you're thinking of which assignments to do, no bias, but we would recommend the first 2. But if you do the 3rd, it's really interesting as well.
I just want to add, the 3rd assignment is very interesting, and it's the one that uses a lot of most modern C++ concepts.
Exactly.
Okay? But for that reason, it is also the toughest one.
Exactly.
Okay? So take your pick.
Take your pick. Choose your own adventure. Late days, again, very chill. So you guys will have 2 24-hour late days. We're not doing lecture days because our lectures are so far apart. And again, one thing that we'll say at the very end is actually if you take this survey, you don't have to take it right now. You'll get another late day. But we're also, unlike some of the other larger classes, where if you have like an issue or a big emergency or something, like come talk to us. Like we're very flexible. Again, this class is for you guys. So again, 2 late days officially, but talk to us if you have anything. That said, we do want to give our graders enough time to grade your assignments. So yeah, keep all of that in mind. Work with us. Development, so we'll be using the IDE called Qt Creator in this class. If you've already taken or are taking 106B or X, you should have it installed. If not, then if you go to the next slide, slide 27, if you go to the cs106b.stanford.edu website, there's a header called Qt Tools that has a bunch of PDFs under it. Those website links actually have step-by-step directions for how to install it based on what type of laptop you have. So if you follow those, you should be good because Stanford's tested them out really well. If not, if you're running into any issues with Qt Creator, and trust me, if you are not alone. Qt Creator is like, it's our frenemy. It's the best friend that we hate. There's a troubleshooting session for all of the 106B and X classes on Thursday at 7:30 to 9:30. That's where you can go and they'll help you get it set up. So if you go to that and still can't figure it out, then as a last resort, we will also sit down with you and work through it. But we can't promise that we'll give any better advice than the people there. And then the last thing.
Question.
Yes.
What is a layer?
Yeah, great question. Okay, so the layer, for anyone who's not familiar, is a feature of the CS106 program. It's the office hours for 106A, AX, B, and X, and it takes place in Tresidder Union, around where the ice cream place is. Say that again?
Decadence.
Decadence, around where Decadence is. So the way that you use the layer is there'll be a laptop there that you can sign up, and you can ask anyone around you where the layer sign up is. You sign up, and then someone will come over and help you soon. Yeah, and if anyone has questions about the layer especially, like also email us with any questions like that. The last thing, of course, that we want to emphasize is honor roll system. Don't cheat. It's the same rules as any of the other CS classes that you've taken. If you have any questions about this, feel free to email us. Perfect.
All right, I'll keep going. Just a comparison of CS106B versus L. In L, we have 2 lectures a week. We don't have section. Okay. Next. In a couple weeks, you will be assigned a section leader, but you won't actually meet with them. IEGs are not required. All that will happen is they'll read your assignments.
Yeah.
Okay, but that will happen after ad drop is over.
Yeah.
Unit-wise.
Yeah.
Oops, wait. Oh, yeah. Okay, so CS106B, you know about CS106B if you're taking it right now. In 106L, this is the 1-unit class graded pass-fail.
Yeah,
Okay?
and auditors are welcome. If you can't take this class because of unit counts or something, definitely feel free to sit in and learn as much as you can.
Yeah. For SCPD students who will be watching this on video, we're sorry we can't accommodate you in this class, but auditors are welcome. Okay. In this class, there are 3 assignments, and you only have to choose 2. And, there's some debate about this, but these assignments are generally much shorter than the 106B ones.
They're much shorter.
So have fun in 106B.
It's a really good class. All right, so that deals with all of the logistics, everything before that. Before we move on, does anyone have any questions that they want to ask now? Yeah.
How long do the assignments take?
Sorry?
How long do the assignments usually take?
Oh, the assignments usually take. The first 2 assignments, I'd say.
Are they shouldn't take more than maybe max 5 hours.
Yeah.
Max would be 5 hours, but even that would be quite a while. If you're feeling stuck on any assignment, they should really correspond pretty closely to the things that we've been learning in class. So come talk to us if so. But a lot of people, especially the first 2, can get them done pretty quickly. Yeah, they're mainly meant to be more of a check that you've understood what we've taught rather than a very challenging. Yeah.
In addition, they're also really cool projects.
They are very cool.
Yeah. These assignments, we don't ask there's not too many features we ask you to implement, but they're a really good launching point to create your own feature in those.
Yeah.
As an example, the first assignment is a graph visualizer. So you'll be given some sort of graph, and then you'll implement an algorithm which will essentially spread the graph out so that it looks as nice as possible. Okay. So there's a demo that I'll send later, but it's a really cool assignment.
Yeah, exactly. That's a great question. What's your name? Brad? Ben. Okay, thank you, Ben. Yeah, does anyone else have any other questions of any sort? Yes?
So you said that you aren't able to accommodate SCPD students, but are the lectures recorded? I didn't know that they were.
Yes.
So we're considering whether or not we're going to be recording every lecture. Depending on whether there are any students that can't make the class that do want to audit it, we might consider releasing them afterwards. But if there's a strong opinion either way, we might consider.
Yeah, we're considering both videos and screencasts. Right now, these are just meant for us as for professional development, but
improve our teaching.
Yeah, but we will likely share these.
Yeah.
Okay, but please still come to class. Please still come to class. Okay.
That's true. We want to see your lovely faces.
Yeah, yesterday I went to 106B. The class was full. Everyone was happy. Well, unless you didn't get a seat. But this class, there will always be seats for you here. Please show up. Okay.
Yeah, that's a great question. What's your name?
Brandon.
Okay. Yeah, any other questions? Those are all good questions so far. Okay, awesome. So we're going to get, the last thing that we're going to cover for today is some history of C++ because it really informs the things that you guys will be learning later today. So to jump right into it, one more time, I'm holding this up here just to give you guys an idea of what slide we're on, but you'll want to look at your screen because this text is tiny. Okay. So slide 32. So on slide 32, you can see that there is some C++ code in front of you, and you might recognize it. If you've taken 106B or X, and sorry that we keep on referencing it, but that's what we're assuming a lot of people's experience is based on. You'll recognize that as the familiar Hello World basic program. If you go to the next slide, you'll see another program that's actually equally as valid in C++, using something called a printf statement. It looks slightly less nice, looks slightly more confusing. Turns out that's the C way of writing hello world. That also works in C++. And if you go to the next slide, you'll see some code that is actually also valid code in C++ and is another way of writing hello world, in this case using assembly. which is to say that this is not how we want you guys to write C++. But the takeaway from all of this is that C++ is a really big language. And part of the reason for that is because it's built to be backwards compatible with all of the history that came before it. One of the things we want to do is give you guys a brief overview of that history right now so that you can understand why C++ is designed in some of the ways that it is. So, C++ history, way back in the early days of dinosaur computers that that are as large as a room, we used assembly as our primary language, which looks something like this. You might have seen this, and if you haven't yet, you'll most likely see it in CS107 if you're planning on taking that. So why assembly? So some of the benefits of assembly, it's unbelievably simple instructions. So your instructions, you can do things like move a bit around, you can add or subtract two numbers. It's extremely fast, probably in fact the fastest language out there, when well written, of course. And then of course, assembly gives you complete control over your program. You are literally telling the computer what one-by-one steps it needs to make a sandwich, like every inch of movement that it needs to move. So the question is, with all these three benefits, why don't we always use assembly? As it turns out, it's because assembly looks like this, as you guys have already seen. And what that means is, yes, assembly is very fast, but the simple instructions means that it requires a lot of human effort to write code in assembly. To do something very simple, such as even writing hello world, requires a super just obscure, very long paragraph. And in a similar vein, it's hard for other people to understand the code that you have just written. It's like trying to recompile a puzzle based on a bunch of puzzle pieces scattered around the world. Complete control over your program, assembly does provide that, but it does so because it's very specific to the type of computer, device, or operating system that you're running. So someone's assembly code, like that hello world program that you saw earlier, that code might work on one person's laptop, but completely break on another person's laptop because they use a different set of instructions that it understands. And so assembly was just not very practical for anything beyond like one or two people using it together. Which brought us to the invention of C. So C, okay, so writing assembly was necessary because computers only understand assembly. And a lot of this history you'll be hearing again through other classes, so I'll go through this kind of quickly as well. That said, writing in assembly is difficult. What's the solution? One idea, source code should be written in a way that humans understand it and humans write it. Humans shouldn't have to speak to computers in its direct language in order to be able to write a simple program. And so instead, what people did is they built an additional tool called a compiler that then translates the human language to the computer language. And again, all of that you will be seeing in future classes as you go through the CS course. But that's not what we're here for. So I guess some history of C. C was invented in 1972 by these two guys in the picture. It made it easy to write code that's fast, simple, cross-platform. And again, that's the language that you'll be using in CS107. That said, there's one issue with C. So although C is more high level than assembly, oh man, let's see, here we go. It was also not high level enough. So you'll notice with programming languages, they tend to get more complex and they tend to get higher level abstractions. So you're starting to use less and less words that don't sound very natural to the human ear and approaching more and more things like Python, which sound very similar to the English language even. So specifically, these are some issues with C which I want to emphasize because C++ has a lot of features that are designed to address these. One of them is that C doesn't have any objects or classes, which means that if you wanted to make your own Facebook, for example, you wouldn't be able to have an object called Facebook profile. Instead, you would have to be maintaining something like an array where you just know, because you're the programmer, that the first one corresponds to the first name, the second bucket in the array corresponds to the last name, and like the third person, I promise, is your best friend, or something like that. So in C, there's no way to do that, even though now as computer programmers, we take it so much for granted that we can create our own object that encapsulates all of these rules and knowledge into a class. So that's something that C++ actually added and was one of the first languages to add. C as well, difficult to write code that works generically. One of the big topics that we'll be covering in this class is something called templates. And basically, it's a way so that for example, in a metaphorical sense, if you had an object called banana and an object called potato, you wouldn't have to write one peel function for each of them. You could write a single peel function, and no matter what object someone threw at you, as long as it was able to be peeled, you could call peel on it. So that's sort of the general idea behind templates, and C++ does really, really cool things with them. And then, of course, C, as you'll find in CS107, is very tedious when writing large programs. So C++ is really, it's growing to become a language that programmers to use to build projects as big as a browser or a video game, which would not have been possible in C. So welcome, you guys, to C++. For your well-roundedness, you guys now all know that C++ was invented in 1983 by someone called Bjarne Stroustrup, probably pronounced that way.
That's actually pretty good.
Thank you. So again, the goals of the language, you want something fast, simple to use, cross-platform, unlike assembly, and additionally has high-level features. And those high-level features are what we're covering in this class. C has the first three, C++ adds on that last feature. So the evolution of C++, really the first big worldwide effort to get C++ into a unified language was in C++ 1998. Since then, the ones on the bottom in orange that you can see on your screen, those have been the major updates of C++ since. And each of them has brought a new feature that you're either familiar with in C++ 98, and then a lot of features in C++ 11 and 17 that most programmers haven't even heard of. Things like auto, which allow you to not have to declare the specific type of variable, but just say you had a vector of Facebook profiles, of Facebook friends, of an array of phone numbers, or something like that. Auto lets you abstract that away. Cool things like that. That's a sneak peek into what we'll be covering. And most of all, C++ 20 coming out next year also introduces a lot of things. And yeah, again, we'll be going through not necessarily each iteration by itself, but we'll let you guys know what C++ update is the thing you're learning from, and we'll be teaching you guys a lot of the most recent things. So you guys will really be on the cutting edge of C++.
I just want to add that one reason why C++ is getting much more popular now is because if you notice in the past, each new iteration comes out once every 5, 7, 10 years, right? But then now they sort of caught on that C++ needs to keep evolving. So right now, they come up with a new draft of what the standard looks like once every 3 years or so. So C++ is a rapidly evolving language, and that's why many programmers right now think C++ is a very good language.
Yeah, one of the things that Avery actually pointed out to me earlier is that C++ is also learning from other languages. So if you've ever coded in Python, Python has this cool ability where you can, say, declare an array A equals 1, 2, 3, and then you can say something like x, y, z equals A, and it'll automatically know x equals 1, y equals 2, z equals 3. Up before C++ 17, that was impossible. And in fact, most people you talk to about C++ would be like, what? No, there's no way that's possible. Turns out in C++ 17, they came out with something called structured bindings that Avery pointed out to me that are super cool. They basically do exactly what the Python functionality is, which is to say that C++ is very much a living, updating, stealing from its competitors all of its best things, like Instagram to Snapchat. It's very much a living language, and yeah, that's one of the reasons why we're so excited to teach it.
Okay,
Cool.
I'm just gonna quickly cover the design philosophies of C++. Okay, let me point you just to a really important web page right now. Go to Google and search C++ core guidelines.
Yeah.
Okay, and then I think if you search, there's probably a GitHub page that you will find as one of the first results. If you click into that, you'll see the founder of C++. He wrote essentially a set of guiding, basically a really complicated style guide. Okay, so if you go to that, the first section talks about like the philosophy of C++, and just by reading that, you'll find that it's really interesting. Now you won't understand the entire document right now, but some of the principles on there are important to keep in mind as we learn more features. Okay, so I'm just going to point out 5 very important ones. Okay, so the first is C++ is what many people call a multi-paradigm programming language, which means it does not force the programmer to adhere to like a certain paradigm. Let me just explain what paradigms are. So if you've taken Java, Java uses the object-oriented paradigm, which means everything involves classes and objects interacting with each other, right? Even your main function has to be contained in the class. That's as opposed to other languages where, for example, Haskell, I guess, where classes aren't a thing, I think.
Yeah.
Yeah, but in C++, there are many paradigms that you'll look at. The most familiar one many of you are familiar with is object-oriented, but we'll also look at this thing called generic programming, which we'll discuss using templates. And then what other paradigms? So there are other paradigms that we'll be covering. And
dynamic programming, things like that.
yeah.
Yeah.
And then C++ allows you to choose between them, or even combine them together. Okay. Let's see. Oops. Okay, yeah. So for example, if you look at that roadmap, you'll be able to see where all the paradigms look like. All right. Next, an idea is we want to express ideas and intent directly in code, and that's actually what a lot of modern C++ has been doing. So if you look at the next slide, you'll see there's 3 ways of finding the sum of a vector. Okay. So you'll see there's 3 ways over there, and in CS106B, you'll probably be writing the very first way. So that's well, you probably won't use auto, but you'll be essentially going through the vector trying to find the sum of all of them. What we'll be going up to probably at week 4 is we're going to explain why the very last one, the one with accumulate, that one is the best way to sum up a list of numbers.
Yeah.
Right? And there's a reason why. This follows into the more generic programming paradigm that you will learn about. Okay, so in C++, it may seem mysterious why the last way is better, but you'll be able to see why soon. Lastly, let's see. Enforce safety at compile time when possible. We'll not get too deep into this right now, but if you compare C++ with Python, C++ is very insistent on types, okay? And everything is resolved like compile time. So let's see. I don't want to go too deep into this, but that's one of the core principles we'll be discussing. Okay, this is really fun. Do not waste time or space. If you go to the document right now, there is, if you just quickly scroll to the philosophy section, you'll notice that there's a lot of like philosophies, and then there's a reason underneath all of them. Okay, but then if you scroll to the one that says do not waste time or space, the reason is really fun.
I don't know if I'll find it. You can just say it.
Okay. There we go. Okay, yeah. So if you go to that, the reason it says is very, I guess, meta. The reason is this is C++. Okay, C++ is inherently known for its performance. So everything that we write, it's kind of like a weird obsession to an extent, where C++ programmers just worry about performance. How can we speed this up? How can I make this faster? And a lot of the principles, a lot of the features that we create, will be discussing performance. Okay. Finally, compartmentalize messy constructs. This is developed a little bit more in CS106B about like abstractions. We'll see more of that in 106L. Okay. Cool.
Cool.
We have 5
So
minutes left.
yeah. Okay. So ordinarily, what we were going to do is show you guys the first program in Qt Creator, which is basically just proving to you first that all 3 hello worlds that we showed you before are valid programs in C++. And so if you run that code, it should output hello world, hello world, hello world. Because we don't have the projector, what we're going to do instead is I'll send out a Piazza post after this with basically the code to download and then some step-by-steps how to run it. And you can run it yourself and check that what's outputted on your screen is hello world from all 3. And then there's a couple other things that we wanted to show you guys, but we'll do that either at the beginning of lecture or we'll work it in somehow later.
One challenge I have is if you look at the assembly code for hello world, I challenge you to change it so that it prints something else. So instead of hello world, make it print something else. Okay, it's harder than you think.
Yeah, that involves assembly as a language, so not necessarily C++. So you're welcome to talk to us about it as well. Another interesting thing, yeah, like feel free to play around with these programs. We'll also be posting a blank C++ project that you can use to start creating your own programs as well.
Survey.
Cool.
Yeah. Survey?
Yeah. So one thing that I told anyone who was here at 3 earlier, one thing that we want to ask of you guys is a survey that just tells us what your background is and what you want to get out of this class. As an incentive to do it, we'll give you 1 extra late day by filling it out. But that'll just help us figure out like what we should focus on and how we should teach. And that survey is at this bit.ly link. It's also on the slide.
Let me just talk about it next time.
Cool.
Okay, yeah. All right, and then the last thing I want to just quickly briefly mention is if you go to slide 63, that's like one of the last slides. That's basically looking ahead, what will we be covering in CS106L the next week and a half. Okay, so yeah, the next week and a half we'll be talking about streams. All right, and then Cynthia structured her schedule perfectly so that what we'll be doing is we'll be learning about the basics of streams on Thursday. And then Cynthia will be covering file streams on Friday. And then on Tuesday, we'll assume that you've been to class, which I know all of you will. And on Tuesday, we'll build off of file streams to learn how do you implement the standard libraries. Okay? We will actually implement the standard libraries in class.
Yeah, we'll be implementing what you'll be using in other classes. Yeah. Isn't that cool?
Okay. Cool. And then, let's see. Yeah.
So that's everything that we have. Sorry again about the projector. We'll get that fixed before next time. But thank you everyone for following along on Piazza. I believe everyone was following along. I really believe in it. And I really appreciate it. If anyone has any questions for us, now's the time to ask. We'll be standing out here. And if not, we'll see you guys on Thursday.
Is there any way to get the slides also ahead of time, just if you want to look ahead a little bit and get some